In this video, we're going to be taking a look about limits. We have a lamp which is turned on in 1 minute, then turned off in half a minute, and then again turned on in a quarter of a minute, and so on. The on and off of the lamp is represented by this infinite sequence. Now, I want to tell you something interesting. The sum of all numbers in this infinite sequence gives us 2. If you are confused on how some sequence which goes to infinity sums up to a number as simple as 2, by the way, the term convergence is a fancy word which will formally be used here. Convergence means that an infinite series, a series means the sum of all numbers in the sequence, gets evaluated to a finite value. For now, I will give you a quick visual proof to prove that the infinite series we saw converges to 2. We can separate the sequence by rewriting 1 to one side and 1/2, 1/4 and on to another side, and draw a square with side length 1 for both sides we split it. Now we can split any of these squares to represent the sequence 1/2, 1/4 and on, and as you can see, the second square represents the orange highlighted part of the sequence. Both of these squares have side length 1, so each square has an area 1. The summed up area of the two squares is 2. So getting back to what we were looking at. As we saw, the above represents the on and off of the time of the lamp. Now we even further know that the series above converges to 2 minutes. Now that I've told you the sequence converges on 2 minutes, answer this question. At the end of 2 minutes, is the lamp on or off? Pause the video and think about that. This was certainly not a simple question. The answer to this question is undefined, because an infinite series does not have a last value. The question I asked was like asking, is the last digit of pi odd or even, when pi does not even have a last number? Calculus uses a lot of limits. Derivatives and integrals are the main focus of Calc 1 and 2, and they themselves are limits. Let's take a brief review of sequences. This is a sequence. A sequence is an ordered set of numbers in some order. The dots represent this sequence goes to infinity. If the terms of a finite sequence are added to obtain a finite sum, it's called a series. Below is a simple sequence, which is the sum of all numbers from 1 to 4. This is a series because it is the sum of a finite number of terms. If a series is infinite, then the sum up to any term is called the partial sum. Below you can see that we have an infinite sequence, so the sum to any finite term is called the partial sum. Now let's get into limits. The definition of a limit is if the partial sum of an infinite series gets closer and closer to k such that by continuing the series, you can make the sum as close to k as you please, then k is called the limit of the partial sums or the limit of the infinite series. Let's look at an example. We have seen this infinite sequence before and we know it converges to 2. Let's start by taking the partial sum of the first 4 terms, next the partial sum of the first 6 terms, and now the partial sum of the first 10 terms. If you look carefully at the 3 partial sums we took, then you can find something interesting. The more terms we have in our partial sums, the closer and closer we get to 2. So 2 is the k from the limit definition and is considered the limit of the infinite series. Mathematically, we would denote a limit like this. Limit as x approaches a of f of x equals b. Lim is a short form for limit, and the arrow below shows the value our x variable is approaching. The f of x is the function or sequence we are taking the limit of. So now let's try and write the limit for the example you are seeing in limit notation, and we would get this. We have n instead of x for this example, And you can see we're approaching infinity because we're getting bigger and bigger values of n. Now we have 1 or 2n as our sequence which are taking the limit of. Now try yourself to find the limit of the following. Pause the video and try to solve these on your own. Now let's interpret limits from graphs. Here the limit as x approaches 2 is 3 because you can clearly see 2 maps to 3 is the coordinate. But let's calculate limits in a slightly more formal way. A limit needs to have both one-side limits to be equal to some value c in order for a limit to exist. There are two one-side limits for a point. The one-side limit with the superscript plus shows we are approaching the limit from values greater than the limit. An example is shown in the right side of the screen. Now for this graph, you can see from the animation that the limit as x approaches superscript 3 is approaching 3 from values greater than 3. Now the other one-side limit is the limit with the superscript minus, which tells us we are approaching a limit from values lesser than the limit, as you can see in the graph. Now let's think about both one-sided limits together, as you can see in the graph on the right. Because both one-sided limits are approaching the same value, a limit exists. If both the one-sided limits don't equal each other, then a limit does not exist. Look at the example on the right of the screen. You can see that the one-sided limits are approaching different values, so a limit does not exist for the space-wise. In limits, when we say approaches, we mean we want to get infinitely close, but infinitely close is very abstract and is not possible in reality. So by mentioning limit as x approaches a equals b means that no matter how close we want to get to b, there's always an x value very close to it that will get us there. So getting back to the example we are seeing, because both one-sided limits approach 3, we say a limit exists. Now I've given you some problems. Pause the video and try out these. We have a challenge for you. We are giving you a challenge to complete the understanding quiz, which is present in a link in the description, and post your answers with #InsideQuiz, and see you all next time.